Hello guys, and welcome to another discussion video with your statics of rigid bodies. Alright, so in this video we are now already with module 6, which is we will talk about that later. So on the last module, the structural analysis module I wasn't able to make a video discussion, but just to aid your learning, so aside sa akong PowerPoint yung gihatag, diba, I have attached my PowerPoint presentation sa inyong e-learning, so you can just read it. So na dito ang mga as simpler nga pagka-discuss is ako siya gibutang dito. But again, if naglisod pa dyan mo sabot sa PowerPoint, so moto I decided to ask Sir File if I could use his video discussions regarding structural analysis. Alright, just to aid your learning towards your method of joints, which is very easy lang yun siya, diba? Your method of joints was simply mura ra jud kag nag vector. Alright, if I know nga hanas na kay mag vector because kapila na siya balik-balik. Now if kabalo na kamo perform vectors, okay, vector operations, then di na kay ka maglisod sa imuhang method of joints. Then sa atong method of sections is almost the same na gigihapon siya, vectors nang gihapon, ato lang gigamitan dito siya og moments. Okay, nagamit na tag moments just to eliminate mga or reduce the unknowns para makasolve tag mga specific nga mga members. Alright, so I guess kabalo na punta dito nasa PowerPoint na gibutang kung kano sa advisable magamit si method of joints o kano sa pod advisable gamiton si method of sections. Alright, then now to last nga topic, extra nga topic which aids us to shorten, okay, para mas madali ato computation. What are the zero force member? So dapat kabalo na ka kung asa diha ang zero force member, because again, if kabalo ka kung asa ang zero force member, it will shorten your time, because again, dili naman to nimo siya agian because kabalo naman ka nga zero force member to siya. Okay, so that was all about your structural analysis, ang ato ang analysis of truss specifically. Alright, anong method of joints and method of sections. So without further ado, let's proceed with our next module, which is all about your internal forces. So sa atong internal forces is we just simply employing ato diri gamiton ng atong knowledge with method of sections. Okay, we will talk about that later. So in this module we are just going to talk about these two topics. First is what is the concept of internal loading. So unsa ang iyang importance, then how are we going to solve internal loadings, and then we are going to draw the shear and moment diagrams. So unsa pay gamit sa shear and moment diagrams. So what is the very essence of these topics. So heads up lang, ang kaning topic ang module 6 is I did my best, okay? I did my best to shoot this discussion video, alright? Because if ever nga dili na ako ma-discuss og maayo is you might be having hard time, especially if nanamo sa inyong higher nga mga subjects sa atong structural analysis, theory of structures, atong strength of materials, because again, if wala may background sa internal forces, maglisod mo og catch up sa mga higher nga courses. Alright, so let's get started. So the objective of this module is first is we are going to determine the internal forces of a member. So ang atong gibuhat sa chapter 5, sa module 5, katong structure, method of joints and method of sections is almost the same lang gihapon siya. We are determining the forces, okay, the internal forces mo to siya sa mga member. Alright, so mag-cut sa method of section is we are going to cut, tapos i-expose na to para mabalaan na to if that is compression or tension. So ang kalahian lang niya dire is ang ato ang diri sa module, kani nga module 6 is ang ato ang member is subject to different internal forces. Unlike sa atong structural analysis, sa ato ang mga truss members, alright, sa atong mga truss members is kabalo ka, di ba, ato gi-assume dito, we have assumed that our truss members are only subjected to one force, that is your normal force. So ang imo ra diha choice is either tension or either compression, mao lang. So unlike diri, okay, kani nga chapter is we are going to discuss the different internal forces or internal reactions sa isa ka member. Alright, then after that, if kabalo na ta kung unsa ang mga internal forces, is we are going to represent and draw the shear and moment diagrams of a member on different loading conditions. Okay, so kabalo na mo shear moment diagrams. Next, internal loadings. So, to use the method of sections to determine the internal loadings in a member at a specific point. So, that is the objective of this lesson. So, ang iyang gingon diha is we will be we can determine, okay, kaya nato masabtan ang internal loadings sa isa ka member if we are going to use the method of sections. So, di ba ang method of sections nato is we are going to pass a section, okay? So, mula ba magbutang na dihag section, so kailan mo siguro tag section, di ba? Because nanamhuman naman mo drawings, alright? So, we need to pass a section at that point kung asa ni mo gusto ma-determine ang internal loadings, then dito na mo gawas ang ato ang mga internal forces nga atong i-determine. Okay. So, what is the importance of internal loadings? So, to design a structural or mechanical member, it is necessary to know the loading acting within the member in order to be sure the material can resist this loading. So, the material can resist. Alright? So, wait. Okay, that the material can resist this loading. So, ang importansya daw sa internal loadings is simply dili ka makadesign, dili ka makapili kung unsang materials mo gamiton kung wala ka kabalo kung unsang internal loadings niya. For example, in this figure, okay, this is a steel structure. Okay, nga naman, steel structure, diba? Because ang iyang column, ang iyang beam, ang iyang joist, ang iyang floor is made of steel. So dili ka maka-design because again if you will encounter that on your principle of steel design. We have different steel sections. Okay, natay mga W sections, natay mga S sections, I sections. So daghan mga channels, angle bars. So daghan I know kakailam sa uban. Okay? So dili ka daghan na siya mga sukod na ay mga W8 by 14. So something like that. Daghan ka na sila mga different types of sections. Now, dili ka makapili sa imong design, dili ka makabutang og unsa na sa nga sections if you don't know kung unsa ang internal loadings nga ni-occur ana nga member. Okay? Usa pa diha, unsa importance. If we are going to design a structure, okay, either steel or either concrete, ang atong concern diha usually is the maximum shear force and the maximum bending moment. Because again, si shear force, ang maximum shear force is mao na ato basihan if we are going to design the stirrups. Kailan mo tag stirrups, di ba? Stirrups or ties. Mag-design ka sa imong stirrups or mag-design ka sa imong ties, ang basihan nimo diha is si shear force. Okay? Now, if dili ka kabalo kung unsa ang pagkuha sa shear force, of course, dili ka ka-design sa imong stirrups. The same with your bending moment. Okay? Si bending moment is usually siya gyud na ang basihanan kung unsa kadagko ang kabilya nga gamiton, pilay spacing sa imong kabilya. Alright? So, si bending moment ang basis nimo unsa nimo pag-design ng imong structure. Now, if you don't have the background of this concept, kaning internal loadings, is you will be having hard time to design your structures. Alright? So, that is its concept. Now, internal loadings can be determined by using the method of sections, di ba? Ang sa method of sections nga concept is if body or ang isa ka structure is equilibrium, meaning stable siya, okay? If a certain body is in equilibrium, the section also must be in equilibrium. Maski asa ka mag-cut sa imuhang structure, all the sections nga imong pilion should always be in equilibrium. Alright? So, for example, this is a cantilever beam. Kailan naman, I hope nga kailan mo sa mga dito ako gi-share gani nga meme sa ato ang group. Alright, katong different types of dapat kailan na mo what is a simply supported beam, dapat kailan na mo og what is a cantilever beam, o kailan na pud mo og what is a simply supported beam with overhang, tapos napay usa pero wala pa na diri sa ato ang subject sa atong course, that is a prop beam. Okay, kung yung prop beam, the same dire, this is a cantilever beam, whereas ang prop beam is a cantilever beam with a roller. Okay, na siya roller diha. That is a prop beam. Pero di wala natin siya i-discuss diri because that is a statically indeterminate nga structure. Anyway, if this is a cantilever beam, tapos we are going to cut, for example, we need to know, okay, we wanted to know the internal loadings at point B. Okay, so therefore, we need to pass a section about point B, just to expose these internal loadings. Now, unlike sa ato ang truss, okay, unlike sa ato ang truss, is kabalot nga ang member na to is it can either be tension lang or compression. So, duha lagi di mo choice diha, tension or compression. But diri sa ato internal loadings is we might, okay, we might, okay, sure jud ka nga naa kay masugatan diha nga a maximum of 4. Okay, we will discuss that later. 4 internal loadings. Ingon ani iyang porma. Natay moment, naatay forces. Okay, and we will discuss it later one by one. All right? So, according to the Newton's third law, these loadings must act in opposite directions in each segment. So, therefore, we have 4 general internal loadings that may act on a member. Kaning tulo, kaning first 3 is always gini sila present. Unsa man, kaning normal, shear, bending, they are always present maski 2-dimensional or maski 3-dimensional. Always yun na sila. Kani si twisting moment or torsion, you will encounter this sa inyong mechanics of deformable bodies, inyong strength of materials, ma-discuss ito si torsion. So this will only occur sa ato ang 3-dimensional nga system. But for this module sa ato discussion is we are going to talk only with 2-dimensional or coplanar nga analysis. So ang atong masugatan diha usually is si normal, which is denoted by letter N, shear force, that is your letter V, tapos bending moment or usually called as your flexure, okay, that is denoted by letter M. So ang buti pasabot niya dire, okay, for example, the same kaganina, if we are going to consider this beam tapos magkatadhag section, all the forces, internal loadings should act opposite at each segment. For example, diri nga segment from A to B, kung si N nimo, ang imong normal force is padong sa asa man nga force, padong sa imuhang right, okay? Kung padong na sa imuhang left, padong sa imuhang left, okay? So kung padong ni sa imuhang left, dapat sa imong pika segment that should be to the right. Okay, that should be to the right. So yan na opposite. If this is counterclockwise, this should always be clockwise. Opposite dapat na sila always. Okay? Then, normal force. Okay? So, kani siya, ako pagiging ganina, this is only applicable. Ang magawa sa dire sa 2-dimensional is kanira silang tulo. That is your shear, that is your normal, and your bending moment. So, duha ka force, usa ka moment. Pero if that is 3-dimensional, nanadiha ang torsional moments, tapos naapod tay bending moments, so duha ka moment, bending and twisting, tapos naapod tay duha ka force, that is your normal and shear force. So, ay lang sa ni-focus kay maglabad inyong ulo. Right. So, let's proceed with normal force. So, ato siya tagsa-tagsaon. So, these are the internal loadings for 2-dimensional loading. So, first, this is your normal force. So, this is the force component acting perpendicular to the cross-section. For example, okay? For example, imo ni siya gitunga, for example, okay? Imo siya gitunga. Then, you are going to face, mag-atubang ka sa imuhang cross-section. That is the force that is acting toward, okay? Kung ano perpendicular man, because this is your area, okay? This is your area. Then, you are going to apply the force, so that is perpendicular sa imuhang area. So, meaning, in other words, that is a pushing or pulling effect sa imuhang beam or sa imuhang member. Alright? So, always remembering nga nagyud tay always sign convention, okay? Sa diri nga course is, diri nga module is we have this sign convention para mas madali. And you will take this hantod sa mo graduate mo. Okay? Because this is the usual sign convention nga ginagamit sa practice. Alright? So, for sign convention, ang inyuhang normal force, mapositive na siya if it tends to pull the member. So, kung tension ang imuhang normal force, that would be a positive normal force. Now, for example, if you are going to consider this segment, okay? This segment, para always na mag-assume, okay? For sign convention, your normal force is always pulling. The same po dire, pulling po na siya. So, based ako previous po niya kani, these forces, act at opposite direction, which is true. Diba? Opposite direction siya. Pero again, ang iyahang effect should be pulling effect or tension. That is for your normal force. Now, for your shear force, or denoted by letter V, this is the force component acting tangent to the cross-section. Pero sa ganina, if this is your area, kung ang normal force is padulong dito, your shear is along sa imong area. Okay? Along sa imong area. So that is tangent to the cross section. And this will have a turning effect. For example, this is your segment for example. Tapos na adre mo force. 'Di ba? It will tend to turn your member. Okay? So that is a turning effect. Now, what is the sign convention for your shear? Alright? So your positive shear, para positive ang imuhang shear, it tends to rotate the member in clockwise manner. For example, kaning nga segment. Para kaning nga segment is mo rotate padulong clockwise, okay, dapat ang imuhang shear is paubos. Diri pod, para mo rotate ni siya clockwise, dapat ang imuhang shear pababaw. Kani pod nga member, okay, kani nga member, if you are going to rotate this member pa clockwise, dapat kani is pababaw, kani is paubos. So that is simply your sign convention for shear. Okay? Again, sa ato ang normal tension dapat para positive. Sa ato ang shear is clockwise dapat ang member kung imo siya i-rotate. Alright? Then last concept, the last internal loading is your bending moment or denoted by letter M. Now, this is the moment acting on the segment at a specific point. So, wala if mag-cut ka diha nga section, always yun na mo gawa si moment. Okay? So, it will be a bending effect. So, if this is your, kanita kay soft siya. Okay? For example, this is your beam. Okay? No, dili siya. Kanina lang. Okay, for example, this is your beam. Your bending moment should tend to bend. Okay? Mabawag ni siya. Mabawag ni ang imuhang lapis or ang imuhang beam. So, maana siya. Now, for sign convention, mas mo ni siya pinakadali ni hinumduman. What is the sign convention of your moment? Kung ang imuhang beam is mo smile, okay? Kung ang imuhang beam is mo smile, that moment is positive. Diba? Sana all. Okay? Sana all. So, always remember that a positive moment will make you smile. Charot. Okay? So, mora na siya hinumdumi. Sign convention is positive moment if the beam will smile. So, positive moment, smile. Okay. So, that is your 3. So, mora na ito i-consider karon diri nga topic because on the first chapter of your hopefully if makapasar mo diri, hopefully, okay, you will be taking mechanics of deformable bodies. And the first chapter of your mechanics of deformable bodies will be talking about stress. Now, si stress, alright, si stress is ang iyang gikinahanglan nga concept would be internal loadings. Now, if wala mo'y kabalo or wala mo'y kaalamag, ha? So daw? If wala mo'y alamag sa internal loadings, you will be having hard time for that course or for that subject. Alright? So that is your internal loadings. So let's proceed with the general procedure. So ano to siya pag-determine. So first is support reactions you go always. Okay? Pero not all the time because not na may uban nga dili na necessary. Wala kay, example, magpili kag duha ka choice. For example, cantilever beam for example. Okay? So cantilever beam is usually ngadto ka sa member nga walay reaction sa ngatong overhang kay para dili na ka magkuha og support reactions. But for simply supported beams sa mga unsa pa diha nga mga beams it is really necessary to solve for the support reactions. Pero sa'yo naman na, okay, you just have to practice. So nga ra jud na always mag-start. Now, sa pagkakaroon is I really advise you to practice solving support reactions because gikan diri, okay, gikan diri nga scores hantod sa mag-graduate mo is permanently first step si support reactions. Now, if dili mo kabalo mo og support reactions at a very short period of time, okay, maglisod mo. Okay? Kaya again, if malangay mo sa support reactions, it will consume, example, ang inyong exam sa theory of structures, okay? Ang inyong exam sa theory of structures is 1 hour lang. Tapos, ang imong pag-solve sa reaction is 30 minutes, for example. Now, 30 minutes is not enough for your structural analysis sa theory of structures. Okay? Kaya daghan pa kay agian diha, mga portal method, mga daghan. Okay? Daghan pa. Now, if malangay na ka sa support reactions, problema na ka na. Okay? So, better practice solving support reactions. Okay? Then second is you are going to pass a section. So mag-section na ka kung asa nimo siya gusto ibutang, kung asa nga point ka gusto makabalo sa iyang internal loadings. Then after that is investigate, okay? Or pwede mas safe is you draw na lang each segment, okay? Pero usually investigate raman yun na. You investigate kung kinsa nga segment ang least number of loads, okay? You have to choose the least number of loads nga naman para mas dali, of course, okay? Para mas dali nimo siya i-solve. Paspas kay ka makasolve diha kung gagmay lag loads. Then after that is you are going to apply now your equilibrium equations, your summation of forces x, summation of forces y, and summation of summation of moment. Okay? Now, diri nga part, ang advisable diri ngadto ka mag-moment sa kung asa ka mag-cut. Okay. Para mas makagets, let's proceed with the example. Okay. For your assignment 9, okay, for your assignment number 9, you solve this problem. Okay? So, kabalo na mo sa you know the rule, so just submit it on the deadline. Okay. So, for example, 6.1. Determine the normal force, shear force, and the moment at point C. Okay? So, marita sa ato ang whiteboard. Okay. So, first step is we need to solve for the reaction. So, dapat easy na lang kaya ninyo ang reaction. So, we have here at BY. Diretso na lang na. BY. This should have natay EX dapat diri because since wala man tay X component, di ba? Mag-solve ka diag X component is wala man kay ma-solve nga X. So, obviously, your AX is equal to 0. So, dere, this would be 12 kilonewton. Zoom. 12 kilonewton with a distance of pila? That's 1.5. Tapos diri ako na siya i-simplify diri siya, that is 9 distributed load tapos multiplied by the width, that is 3. So 9 times 3, that should be 27. Okay? 27 tapos nag-act siya at point C ra pud gihapon because that is the centroid of your force, distributed load. That should be 27, then the distance would be 1.5 gihapon. Okay? Again, if I really advise you nga dapat diri pa lang, diri nga part is dapat dili na ka maglangay. Okay, dapat kabalo na ka mo shortcut sa distributed load. Okay, dapat maayo na ka ba ng okay, distributed load ni siya mo ni ang iyang resultant force. Okay, you practice good. Okay, so mo lang nato ang forces, so we can just solve the summation of moments. Summation of moment at A is equal to 0. Clockwise moment should be positive. So therefore, this would be summation of moment A, that should be 12 times 1.5 plus 27 times base of figure, that should be 4.5. Diba? Then minus BY multiplied by 6, that is equal to 0. So therefore, BY is equal to 12 times 1.5 plus 27 times 4.5 minus, okay, divided by 6. That should be 23. Oops. 25 kilonewton. And that is upward. Okay? Adyo na kalimti ang imuhang direction because it will matter later. Diba? Okay, so that is your BY 23.25 upward. Now, we can just do summation of forces Y. Okay, summation of forces Y. So, we can just solve your AY by summation of forces Y. That should be 23.25 minus 12 minus 27. Therefore, your AY is negative 15 pababaw. Okay. That should be 15 0.75 kilonewton. And that is also upward. Again, okay, summation of forces y lang na siya. So, makuha na ni mo din si AY. So, di ba? Reaction pa lang to, pero medyo dugay na siya. So, if you're going to practice, good practice, dali na kayo na siya dapat dali na kayo na nimo i-solve si reaction. Because again, first step pa lang ta. Okay? First step pa lang ta sa tong goal. So, if first step pa lang na siya, then we can, okay, wala pa dahi. We can pass a segment, okay? We can pass a segment about, so, buta na to diri si A. This would be your AY, tapos this would be your BY. And nakay 12 kilonewton diri, and C, distributed load, which is 9 kilonewton per meter. And we are going to get the section at point C. So, diri pa lang, okay? Diri pa lang is mag-investigate na ka kung kinsa nga segment imong gamiton. Okay? Diri ba ka or diri nga ba ka? So, based pa sa atong drawing is masayon diri nga part because again, gamay ra ang loadings. Okay? So, remember, okay, especially if you are dealing with distributed load, ayaw ni siya i-simplify. Okay? Ayaw ni siya i-simplify if mag-cut mo. Gi-simplify lang nato siya diri para makuha si reaction. Pero if you are going to cut the section, ayaw siya i-simplify. Use it as it is. Okay? Kung distributed na siya, you use it as distributed load. Okay? So, now, let's just isolate the section. The segment, rather. Okay? So, that is C, 1.5 na ang iyang distance. Okay? This would be 1.5 meters. What are the forces acting? That is your, what is the value of your BY gani? BY is 23.25. Okay? That is 23.25 kilonewton. Then, naatay distributed load diri nga 9 kilonewton. Then, ayaw jud kalimti, ipagawas na nato ang mga internal loadings. Again, this is our member, so this would be our normal at C. Again, tension na ha, tension mo nang going away with the member or the segment. So, tension na siya nga normal. Tapos shear, okay, unsa na to direction sa tong shear? Your shear should be upward. Okay, that should be your VC. Ano upward man? Because if this is upward, it will rotate the member clockwise. Okay? So, manang upward. So, I hope nga makagets. Then, lastly is si kinsa, your moment. Your positive moment, okay, your positive bending moment should be smiling moment. Okay, dapat ang beam na to is mo smile. So, para mo smile lang ato ang beam ngayon ana, it will have a moment ingon ana nga moment. So that would be our moment at C. Okay? So I hope maklaro. Again, your normal is tension para positive. Your shear is rotate siya clockwise para positive. Then your moment that will make the beam bend or make the beam smile. Okay? So muna siya. Concave upward. So if na imong free body diagram, very easy na lang na siya. Sama na siya. Let's start with the summation of forces X. So, base diri, the right forces are positive. Ano siya off? Okay? So, wala man tayo X nga forces diha. So, therefore, your NC is equal to 0. Okay? So, that would be our normal at C. Now, how about your shear at C? Summation of forces Y is equal to 0. Upward forces are positive. So, that would be, positive na to is VC. Sa pailain positive. Plus your 23.25 kilonewton. Okay, later na lang ang unit. Then, downward na to is si distributed load which is 9 multiplied by 1.5. Okay? Ato lang siya i-simplify diretso. What is the reduction of this force? That would be 9 times 1.5. 9 times 1.5. That is equal to 13 point. Ang iyahang distance diri would be 0.75. Kato nga ni 1.5. So, 0.75. Okay. So, that should be equal to 0, di ba? Alright, so what would be the value of our shear at C? That would be 9 times 1.5 minus 23.25. This is negative 9.75 kilonewton. So, dere is, di ba natin andan is, kung negative gani on the opposite side, wala, di ba? Dili na siya applicable dere, meaning, as is gana siya. Okay? As is gana siya because it will be used later sa ato ang shear and moment diagram. Okay? So, kung negative na siya, as is nga, negative shear. Okay? So, therefore, our shear at C is a negative shear. Then, lastly, is we're going to solve for the moment. So, obviously, we need to use summation of moments. Ako pag-ingon ganina, mag-moment ka kung asa ka nagputol. So, dire is nari man nagputol man ta dire ganina ni C. So, let's moment at C. Clockwise moments are positive. Ngano sa C man ka, sir? Kay para para makancel ang ato ang NC kanang red, okay? Para makancel na si red o kanipod si green. Ingara man ta mag-moment ni C. Para ang mahabilin nato ang ano ni C moment. Okay? So, sakto no. So, therefore, this would be MC. Positive ba na siya? Isa pala yung positive moment. That would be plus your 13.5. Ang iyang moment arm is 0.75, di ba? Your distributed load. Ang nakabilin is si negative 23.25. That is your reaction. Then multiplied by the moment arm, which is 1.5. Then that would be equal to 0. So what would be the value of your MC? That is 23.25 times 1.5 minus 13.5.75. Dapat paspas na kayo mo magsubog reaction para di mo malangay. This would be 24.75 kilonewton meter. That is a positive moment. Okay. So, that's it. That is our reactions. I mean, internal moments. I mean, internal forces. Normal at C, force at C, and moment at C. So, let's compare our answer if that is correct. So, for normal, we have 0. Okay, again, kaya wala man tayo X nga force diha. For shear, we have negative 9.75. And then for C, we have positive 24.75 kilonewton meter. So, I guess our answer is correct. Okay? Sorry. Okay, so let's proceed with this next example. So again, advice ako ninyo is you practice good. You practice solving reactions para mas madali. Okay? So the same gihapon, let's solve the normal force, shear force, and the moment at C. Okay, so let's start with the reaction. So, wala gihapon tayo BX. Okay, wala gihapon tayo BX. Nga naman, wala man tayo laing force. So, this would be our BY. Tapos, reaction sa ta. Our A. The distance is, pila to distance? Mura to importante. 9 feet. Simplify na to ang distributed load. That would be 3 times 6, which is 18. Acting at the midpoint. So, that would be 18 kips. Alright? And the distance from A is 3. Katunga ni 6. That should be 3 feet. Okay? So, diha pa lang, makuha na to si AY. Or summation of moment na lang ta. Summation of moment at A is equal to 0. Clockwise moments are positive. What tayo clockwise moments, di ba? Wala tayo clockwise moment. So, therefore, this would be negative BY multiplied by 9 minus 18 multiplied by 3 is equal to 0. Therefore, ato BY DI is negative 18 times 3 over 9. That should be 6. Or, ang ato ang BY is acting downward. That should be 6 keeps. The direction is downward. Okay? Namdumi na siya ha. Because the direction of your reaction will matter. Okay, mamatter gina siya. Then, summation of forces Y, that would be 18. Okay. AY is unknown. So, pwede natin mag-shift solve. That would be AY. Sorry. Summation of forces Y is equal to 0. Upward forces are positive. That would be AY. Minus 18 minus 6. It will give us 0. So, therefore, our AY is 18 plus 6. that would be equal to 24 kips, and that is upward. Okay. So that is 24 kips na natin reaction. So therefore, mag-section ta ni C. Kung imo, okay, investigate na lang ta. Kung ato gamit ato na mag-segment ta at point C, ang ato ang gamiton nga segment would be segment CB. Okay? Kaya para mas gamay rag force, that would be segment CB. It would be C. So therefore, mugawas diri C, tension ta. That would be your normal at C. Your clockwise na maghihapon ta, that would be your shear at C. Tapos we have smiling moment, that would be your moment at C. Then let's use the reaction at B, which is downward. Okay, ako siya batang diri. That would be 6 kips. Okay, so diri pa lang sure na ka nga your N by investigation, your normal at C is equal to 0 kips. Okay, wala man kay X. How about your shear Y? Shear Y, your shear at C. Your shear at C is the opposite. Okay, di ba? Duha ra man sila ka forces, so this would be equal to positive 6 kips. Okay, so ano lang siya. Then, ay di maklaro di ay. Shake off. Okay. Then your moment, nga rin mo moment ni C. Okay? Summation of moment at C is equal to 0. Clockwise moments are positive. So, clockwise moment kay CMC. Clockwise na siya. Then, negative moment. Isa pa yung negative. Ay, clockwise gapon ni siya. Your clockwise moment is 6. What is the moment arm? 4.5. Okay, so this is 4.5 feet. So, multiply ni siya to 4.5 feet. So, wala nilain. That would be equal to 0. So, therefore, what is our moment at C? Bending moment at C. So, that would be negative 6 times 4.5. So, that would be negative 27 kips. Okay. So, mura na siya. Very easy. So, let's check if our answer is correct. That would be NC is 0. VC is 6 kips. Tapos, your moment at C is negative 27. Okay, so that is how we going to solve your internal forces. So determine the internal normal force shear the same hapon at point C and point D of the beam. So diri is na natay X component. So shear na kita sa X component diha. Okay, so let's start with the reaction. So, this would be, ako na siya itagsa-tagsaon ha. This would be 690 times 12 over 13. Tapos, iyahang X is 690 multiplied by 5 over 13. So, pailain. We have the reaction at C. Reaction at B. Okay, the reaction at B. We can make it as our BY. And then reaction at A. This will be our AY. Tapos we have our AX. So let's just include the distances. BY is 15. Tapos B is 10 feet. Okay, so let's just simplify this loading, trapezoidal loading. So, nata sa ubos ha, nasa ubos. So, para mas ma-simplify lang ni siya, ako na siya gibuhat before, I'm going to make this as a rectangle. Okay, naka-rectangle diri. The rectangle would be, area lang na siya. That would be 40 multiplied by 15. Diba? That is equal to, pila na siya? 40 times 15 is equal to 600. Tapos, naka-rectangle sa babaw. Okay? I have here triangle, sorry. I have here this triangle. Kanya akong gi-shade. Okay? Since 60 man ni siya, tapos nag-minus kog 40, so therefore, naka-triangle nga 20 ang height. So therefore, this would be, then the centroid of this triangle, okay, dapat kabalo na mo, the centroid of this triangle is 1/3 of this base. Nga rin mo ko doon, okay, 1/3 of this. So pila man ang 1/3 sa 15? This would be, pila? This would be 5. Tapos ang centroid na ning usa is 7.5. Diba? Katunga ni 15, 7.5, tapos 1/3 ni 15, that is 5. So what is the area of this triangle? That is 1/2 of the base, which is 15, multiplied by the height, which is 20. So pila? That's 7.5 multiplied by 20. That is equal to 150 pounds. Okay, so nato na na-simplify ang distributed loading. So, ato siya ibutang diri. This is, pila na siya? 600 pounds. The distance is katunga diri, which is 7.5. Ako lang itang tangon si 15. Ayun na lang, 15. Tapos, we have your 150. Diba? Pounds. And the distance is 5 feet. Yeah, 5 feet. So, I guess mura na mga forces. So, we can now solve for the reaction at B. So, mag-moment ko ni A. Clockwise moments are positive. So, therefore, this would be 150. Positive man na siya. Multiplied by 5. Si 600. Ang iyang moment arm is 7.5. Tapos, si BY. Okay, BY is a negative moment. That would be BY 15 ng moment arm. Plus your 690 multiplied by 12 over 13. The moment arm is 15 plus 10. That should be 25. And that should be equal to 0. So, diri pa lang is makasolve na ta sa value ni BY. So, wait lang sa ta. 150 plus 600 times 7.5 minus plus 690 over 12. 13 multiplied by 25 divided by 15. This is equal to 1411.5385. This is in pounds. The direction is upward. Okay, importante na siya. Then, we can just use summation of forces y para ma-solve si A. Summation of forces y is equal to 0. Your BY is positive. That should be 1411. Ako lang siya i-store sa B. Okay, ako siya i-store sa B. 5385. Tapos, what are the other downward forces? Minus, sa ubos, minus 150, di ba? Tapos, minus 600. And then, minus 690 multiplied by 12 over 13. Then, plus the reaction at A. Plus the reaction at A. That is equal to 0. So, what would be the reaction at A? AY. Minus 150 minus 600 minus 690 multiplied by 12 over 13. This should be negative 24.61538. Or that would be 24.6154. The direction is downward. Okay, so that is downward. So, na naman tayo reaction. Okay, na natin reaction. Then, let's just choose kung asa ta. Okay, let's start with ato lang butang diri. Asa man dapit si C. Si C is something na adiri. The distance is 12. Okay, later na lang na siya. Let's start with D. Malita ni D anay. D. So, we can just use this segment here. Okay? This segment. Ang last nga segment, that is 5 feet. This is our point D. And this is, ano pa ilain diha? Okay. Si AX dahil kabalot ha, ni AX is since wala may lain X, this is equal to, our AX is equal to whatever value ano niya. That would be 690 times 5 over 13. That is equal to 265.3846 pounds. So, dito ang direction for AX. Summation of forces X lang na siya. Okay? To the right ang direction. So, diri is we are going to use this segment. Okay, kani siya nga segment. So, ako i-expose diri si normal at D. Okay, tension. Tapos, we need this shear at D. So, counterclockwise. Then, we need this moment at D. And that is smile. What are the other forces acting on the beam? That is your 690 multiplied by 12 over 13. And this is your 690 multiplied by 5 over 13. Okay, so dire. So dire pa lang ma-solve na dayon nato si normal at D. Your normal at D is equal to summation of forces X ta. This would be equal to ilan na? So good ta sa equation good. Forces X is equal to 0. To the right forces are positive. Positive moment and positive forces wala ta. So we can just negative ND minus 690 multiplied by 5 over 13. That is equal to 0. Therefore, what is our normal at D? That is equal to negative 690 times 5 over 13. That is equal to negative 265.3846. And this is in pounds. That is our normal at D. How about your shear at D? That is just simply summation of forces Y is equal to 0. So the upward forces are positive. So what are the upward forces? Duha lang. That is your VB, shear at D, VD, then minus automatic equals or gihapon na, that is 690 multiplied by 12 over 13. And that is equal to 690 multiplied by 12 over 13. This is 636.923 pounds. That is our shear at D. Now, lastly is what is the moment at D? Internal moment. So, let's summation moment at D. Clockwise moments are positive. So, wala tayo laing clockwise moment diha. That is only your MD. MD tapos kinsa pailain? Clockwise moment. Clockwise is 60, di ba? 690. That's 690 multiplied by 12 over 13. The moment arm is 5 feet. Ba? 5 feet. Yeah, that's 5 feet. So therefore, this is equal to 0. What is our MD? That is negative 690 times 12 over 13 multiplied by moment arm, which is 5. That is equal to negative 3184.615 pound feet. So that is our moment at D. Okay, so we already have the moments, the internal forces at point D. Now let's go with point C. So asa may imong piliun diha nga member? That's segment AC or segment C to the itong overhang diri. Okay. So masayon diha is si AC. Okay? Ato nga ko ni segment AC. So this would be our A, this would be our C. So unsa may ako mga loadings diha? I have here the reaction. Downward reaction, which is, what is the downward reaction? 24.614. 24.614. That's 24.6154. 6154. Yeah, 6154. And we have this AX. What is our AX direction? To the right. That is AX to the right. Okay. To the right, which is 265. I'm not sure. 265.385. 265.385. And all the unit is in pounds. So muna itong mga internal forces. Reactions. So sa pila na to loading from A to C. So wala tayo lain diha, that is only your distributed loading. Okay, that is all downward. Okay, so pag-awson ako diri si normal, tension ha, normal at C. Pangadto na because that is tension. Diri, asa naman akong shear. To rotate the member, kaning nga member is clockwise, that should be downward. V at C. Okay, I hope mo nakagets nga nung downward ang ato ang shear because it will tend to rotate the member clockwise. Okay, clockwise. Then the moment para mo smile lang sa ato beam, para mo smile si beam is padulong dito. That should be our moment at C. Okay, again, it will make the beam smile para positive moment. Okay, so we know that this value here is pila ni siya? 16. How about the ray? What is our value here? Kabalutangan at 15, okay, at 15 feet, 40 ang iyang value. Now, what is the value here? Okay, you can solve this value here using what? Using ratio proportion. Okay, you can know the value here using the ratio proportion. Ano man? Example, you know that for example, this is your 0 at x is equal to 0. Sa sugod dere, the value is 60, di ba? Now, if the x is equal to 15, diba, at 15 feet, nasa ubos, at 15 feet, the value here is 40. Now, the question is, what is the value here when x is equal to 12? Because again, this is 12 feet, biyan siya. This is 12 feet. We need the value, we need this value, okay? We need this value para makuha na to ang mga internal loading. So, how are we going to solve? Again, you can use your ratio proportion, pero naay mas dali nga caltech nga I'm going to teach you, okay? I'm gonna teach you a very useful na caltech basin makagamitan ninyo in the future. Okay, so using your calculator, okay, you go to mode that, so that should be mode 3. Okay, that's mode 3. So ganun niya itsura. So kani siya, okay, kani si 1, ako lang siya sort of brief nga what you call this concept. Kani si 1 is only for kanang mga single gani nga data, okay, na one variation. Okay, so single nga data tapos magamit ang frequency. So na. Then si 2 ang gamit diri ni mode kanang gingon nilag mode 3 to is if you can notice ang iyang formula is a plus bx. So a constant plus a monomial, okay, bx to the degree of 1. So therefore your mode 3 to, which is your mode stat, okay, that your stat tapos at 2, okay, your mode 3 to, this is very useful if you are doing linear nga mga interpolation. Okay, linear man ni siya, okay, linear man siya interpolation. Okay, so since linear man yung atong gamitan because we are using ratio and proportion, okay, so we are using ratio and proportion, so we can use this mode 3-2. So matutani 2. Okay, unsa ni paggamit sa XY, sir? Okay, kani sa XY is depende nimo, pero para mas di ka maglibog, XY is x-axis tapos si Y is your y-axis. Okay, so diri si x kaning ibutan nimo diri ni x is example 0. Sa 0 ka mag-start equals at x is equal to 0, pila value ni y based to figure diri, di ba? At x is equal to 0, the value is 60. So therefore this is 60. Again, this is very applicable if you are using ratio and proportion, okay, or mga linear interpolation. You can use this mode 3 too. Linear interpolation. This is very applicable. Okay. Then ang imo yung hununduman diri for mode 3-2, okay, for mode 3-2, you need 2 points. Okay, what are the 2 points diri? This would be 060, okay? Okay, 060 meaning 0x, 60 ang y, diri would be 15, 40. Meaning at x is equal to 50, your y is 40. Muna, you need 2 points para maka-plot ka sa iyang line. Because again, nag-plot magukag line ana. Okay, nag-plot kag line. So, at x is equal to 15, the value of your y is what? 40. Okay, this is very useful, especially sa mga board exam. Okay, this is very useful. So that would be 0 at 0, 60, tapos we have 1540. So after that is, if naimo na siya na input, all clear lang ka. Okay, all clear. Then na, stat, nagawa siya. Diha, stat. So you go shift 1. Okay, ngano shift 1 man? Because again, dara si stat, diri, that is 1. Okay, so babaw ni 1 is na stat na kabutang. So that should be shift 1. So you go to regression, okay, narang 5. So regression na siya. Then naa diri mo gawa si y bar, y hat ug si x hat. So unsay gamit na niya? For example, okay na. Nag-drawing mo na, example ang imong calculator is nag-graph na siya. Okay, iyan na plot si 060 o si 1540. Kana si, okay, mag-unat na ni y hat. I mean ni x hat, kana ang number 4. Ang x hat is, ang iyang purpose if kabalo ka sa value ni y. Okay, for example, nakoy kuan dire. At any specific point, ang iyang coordinate dapat, ang iya jud coordinate is x hat, y hat. Okay? X hat, y hat. Okay? Muna siya ang iyahang murag concept. Alright? Now, for example, kabalo ka sa y nga value dire. Okay? Ingutan na ka nga, pilay value ni x if kabalo ko sa value ni y. Okay, for example, okay, value diri nga 55, okay? What is the value of your x if, okay, what is the value of your x if the y is 55? So therefore, known ang imuhang y hat. Okay? So para masabtan nimo si x hat, ang imong gamiton diri is ngari ka ni x hat. So ang imong, so since diri ganina, okay? Since diri ang ato ang known man is kabalo ko nga 15 at 12 ni diri. What is the value of this one? Okay? What is this point here? Okay? Kabalo ko, okay? Kabalo ko nga this point is 12 man ni siya nga unit. So kabalo ko that the x is 12 and I want to know the value of your y. So therefore, ang akong gamito diri as instead of x hat, I will be using y hat. Okay? So I will be using y hat. Again, nga na y hat ako gamit kay si y akong gusto mabalaan. Okay? I hope mo nakagets. Now, if si x imong gusto mabalaan, you use x hat. Alright? So, para makabalo ka sa value diri niya, which is ang atong gamiton diri pod, alright? We need to use y hat. So, what is the value of your x? That is 12. Again, you can use ratio and proportion diri. Okay? Sa mga simple lang ang mga ratio and proportion, mas mayo mo solve. Pero, para ma-practice, okay? Para ma-practice is mas mayo if you use your mode 3-2. So, therefore, the value of your y is 44. Okay? So, kung 44 na siya, therefore, this is 44. Yung 16. It should be 60. Okay? That should be 60. Okay? So, okay, you can check. Alright? You can check if 44 ang answer using ratio and proportion. Okay? But I'm sure of that case since nigawasan yung calculator, that should be 44. So, inana siya. Yung ana paggamit sa inyuhang mode 3-2. Okay? Mode 3-2 lang na siya. Mode 3-2, this is for linear ni siya. This is for linear. Now, if you want to interpolate mga quadratic na mga problems, you use mode 3-3. So, you will encounter that if magamit na ta. Okay? So, let's go back to the problem. Alright? Let's go back to the problem. So, kabalo na ta, this is 44. So, I can just simplify this as a rectangle. Okay? As a rectangle here. A rectangle that has a height of what? A height of 44 and a width of 12. So, pila ato ang resultant force diri. The resultant force that is acting 6 siya, 6 at the center. That should be 6 feet. What is the resultant force of the rectangle? That should be 44 multiplied by 12. This is equal to 528 pounds. Okay. Now for the triangle. For the triangle is kabalo man ka nga this is triangle man na siya, di ba? Now if this is 44 tapos 16 ni siya, ang nahabilin diri would be 16, right? So 60 minus 44, 16. So therefore the resultant force is naa somewhere diri. 1/3 of your 12. 1/3 of your 12 is 4. So therefore this is 4 feet. So dapat sweet na mo yun ng mga centroid. Okay, again, matiguang na graduate na lang mo diri sa engineering. Okay, as long as engineering mo, you will, especially CE, you will encounter this all the time. Okay, distributed loads. So if this is the area, that's just simply 1/2 of the base, which is 12, and the height is 16. What is the resultant force? This is 96. Okay, so let's start with summation of forces X is equal to 0. To the right, forces are positive. That would be NC plus 265.385, and that would be equal to 0. So therefore, what is our NC? That would be negative 265.385 pounds. Next is the summation of forces Y is equal to 0. Upward forces are positive. So what are the upward forces? Upward forces nato is walay. Okay? Wala ta. So there should be negative VC minus pila to adre 24. Okay, 24.6154 minus pagyod sa pila na to, that's 96, and then 528 minus 528 is equal to 0. Pila ka forces? Upat. 1, 2, 3, and 4. Yeah, upat. So therefore, what is the value of our VC? That is negative 24.6154 plus 96 plus 528. This is equal to 648.6154. This is in pounds. Okay, this is negative. Negative na siya. Negative shear. Okay. Then last is, what is the moment at C? The internal bending moment. So that would be the moment. Ngari ko mo moment ni C. Clockwise moments are positive. Kinsa may mga clockwise moments na ako? Moment ko ni C. Wala na pod. Okay, wala na po kayo moment diha. Let's just use this si VC, okay? Ay wala, sorry. Negative man si MC minus si 24.6154. Ang iyang moment arm is pila yung moment arm? 12. Okay? 12 minus your 96, the moment arm is, what is the moment arm? Okay, if this is 4, therefore this is 8. So 96 times 8 minus 528, the moment arm is katunga man ni 12, so that would be 6 po gihapon, equal to 0. Therefore, what is our moment at C? That is 24.6154 multiplied by 12. Okay, negative man si MC, no? Negative na si MC. Kay negative man sa siya dito. Okay, so that's negative moment. So therefore, our MC is negative 24.614 plus 96 times 8 plus 528 times 6. This is equal to negative 4231.3848. This is in pound feet. Okay, so now let's check if our answers are correct. Okay, so what is the normal at C? Normal at C is negative 265. Yeah, that's correct. Shear at C, that's negative 648. Why negative? Why negative? Okay, negative dapat na siya. That's negative 648. And then your moment at C, that's negative 4231.384. Yeah. Then our normal at D is 265, negative 265. Then the shear at D is 636. Okay. And then the moment at D is negative 3184.615. Okay. So therefore our answer is correct. Alright. So I guess that's the last example for this video na lang. Okay. So let's continue our discussion on the next video. So I hope nga, I guess sa katong mga examples, okay, sa tulong example is na-gets na ninyo ang concept on how are we going to solve your internal forces. Alright? So Let's proceed. So maybe let's just continue with the next example. All right. So prepare for your quiz 11. That would be on Monday, February 15. All right. So, okay. So see you on the next video. Bye, yours.